So what we got next is Q is equal to, we got in terms of this cylinder equation, basically you got dt by dr first, and using that dt by dr, you have substituted it into your Fourier's law of heat conduction. This is Fourier's law of heat conduction. In the Fourier's law of heat conduction, you have substituted the dt by dr. It's strictly speaking dou t by dou r. And then the equation that you got here is this one. Okay. So this will be the equation for finding the heat transfer through the cylinder when the heat transfer is happening only in the radial direction, and the temperature change or the heat transfer in the other two directions, that is theta and z, can be neglected. So if that is the case, this is how you will take it. And then uh, if you want the formula for RTH, okay, the formula will turn out to be this: ln higher radius by lower radius by 2 pi kl. So this is the formula for RTH. The unit of this one is again this Kelvin per watt for a So today, based on this concept, let's solve this problem. So here, what you have is a steel tube. So to represent that, I take a steel tube of so and so cross section, and for this steel tube, he has given so and so thickness. No, it's not the thickness. It is the inner diameter and outer diameter is given. So it will have certain thickness. So it will be something like this. Let me move this appropriately. Yeah. Yeah. This is what he has given. So there is a insulation. This part is your insulation. Okay. This is insulation. This red color thing is your insulation. And for this he has given a thickness. Okay. Also he has given the length of this. It should be something like this. This is given as 10 meter. Okay. So essentially there will be three radiuses here. This is R1, this is R2, and this is R3. Okay. So the R1 value will be the inner diameter. The ID is given. ID means inner diameter. It is 5 centimeter by 2. That is 2.5 into 10 to the power of minus 2 meter. I'm converting it into meter. Then R2 is to be taken. It will be in terms of this one. It is 7.6 OD, 7.6 centimeter by 2. That is equal to 7.6 by 2. Somebody tell me. It is something like 3.9. 3.9 and 10 to the power of minus 2 meter. And then what will be R3? Somebody tell me.
3.8, sir.
Here. 3.8, Amma. 3 point, yeah, this is not 3.9, this is 3.8. Thank you for correcting me. 3.5 plus 3, that will be 3.8, yes. What will be R3? Somebody tell me what will be the R3
5.8
value.
into 10 power minus 2.
See, the thing is, here this thickness is given as 2 centimeters. The thickness of the insulation that is over the steel tube is given as 2 centimeters. So if I have to get the radius here, it is R2 plus 2 centimeters. So what is R2? It is 7.6. No, it's not 7.6, it's 3.8. The R2 value is 3.8 plus 2. That will give you 5.8 centimeters. So the R3 value is 5.8 into 10 to the power of minus 2 meters. So you are done with the radius. And then what else he has given? He has given you the K value of the steel. Okay, this is the K value of the steel, and also the K value of the insulation will be 0.2 watt per meter Kelvin, and the hot gas temperature, that is the inside temperature, is giving you as 330 degrees centigrade inside this, and the outside there is air. For that air, what he has given as H outer is given as let me write this H outer here as 60 watt per meter square Kelvin, and inside he has given H, it is 400 watt per meter square Kelvin. Yeah, that's it. Everything that is given in the question you have taken, and what is asking you to find is calculate the heat loss from the tube to the air. Okay, so what is Q value you have to find out. So finding Q value is the question. So for that, what we have to do is we have to take the resistance concept again here. Okay. So for that, what you have to do is you have to draw the appropriate resistance circuit here. So how many resistances you have to take here? How many resistances should be taken? You have to take 4 resistance here. Why 4? Because there is a fluid that is flowing inside this steel pipe. That will amount to the resistance due to convection. Let me call it R convection 1. And on the other side, outer side, you have convection again due to the atmosphere. So 2 H values he has given. And in between you will have 2 resistances. Which one? The first one is for R conduction of steel. This is for steel. And let me grab this R conduction 1. This is R conduction 2. This is for insulation. Okay. So they have R convections represented very nicely. And then you will have Q flowing in this direction. Also, you need temperatures that are there here. In this place, the temperature is 330 degrees centigrade given in the question. And outer side, did he give you the temperature? Anywhere? He did not give you. He is supposed to give it to you. Yeah. Then you take this value as T infinity, that is equal to 30 degrees centigrade. See, without this, it is impossible to solve this problem. So you have to consider the appropriate T infinity value. If this is the case for you in the exam, you consider the general atmospheric temperature. The general atmospheric temperature is 30 degrees centigrade or 25 degrees centigrade. You can take any value for that matter. So you take it appropriately. Don't take it like 100 degrees centigrade like that. It is around 25 to 35 will be good. So let us take 30 degrees centigrade in this way, in this question. Let me put this 30 degrees centigrade on this side. Now, what I have to do is, I have to find out the resistance values. Let me find out R convection 1 first. What will be the formula for R convection? Somebody tell me. Shall I call out the names? Mohan, are you there? 310. Mohan, 310. Are you there? You are not there. So if you don't respond during the class, I'll keep it as absent. So today Mohan is not in the position to respond. So his roll number is 310. I will mark it. Rahul, are you there? 312.
Yes, sir.
Can you tell me what is the formula for R convection 1? R convection simply.
1 by HA.
1 by HA. Good. So it is 1 by HA here, 1 by HA here also. Right. What should be the A here? Can you tell me? What should be the area? See, A is area perpendicular to the direction of heat transfer. What is that area? It is the surface area of the cylinder. What is the formula for surface area of cylinder? It is 2 pi RL. Okay. So what is R here when it comes to convection 1? It is R1. Okay. So you have H value, R1 and L value. Substitute them. You'll get this R convection 1. What is the H value on the inner side? H1. Let us call it as 400 is given in question. 400 watt per meter square Kelvin is given, and then 2 pi R1 value. What is the R1 value? It is 2.5 given in question. 2.5 into 10 power minus 2, and the length is given as 10 meters. So substitute 10. Calculate and tell me the value of this R
0.0
0.0159 Kelvin per watt. So now this value 1 by, call this one. What is this? 2 pi. What should be the radius here? On the other side you are taking. Whether you will take R2 or R3. See, it is R3 that is interacting with the atmosphere. So you should not take R2. You have to take R3 itself. So substitute R3 here into L. So 1 by, what is the H2 value that is given in question? The H2 value is given as 60 watt per meter square Kelvin. So substitute that 60 here into 2 pi. R3 value is 5.8 into 10 to the power minus 2 into L is 10 meters. Somebody tell me this value. What is this value? Somebody calculate and tell me this value. Meanwhile, let me move to the R conduction value.
4.57 into 10 power of minus 3.
4.57 into 4.57.
Yes, sir.
57 into
10 power
10 to
minus
the power 3 Kelvin per watt. Good. So R conduction 1 I need. Somebody tell me the formula for R conduction 1. Okay. Oh, Venu Madhav, are you there? 362. 362. Venu Madhav. You are not listening to the class. So I'll mark you absent today. 362. Good. Sai Nickel 364. 364 Sai Nickel. Are you there? Three 64 also I will mark absent. 69. Chandrakiran, are you there?
Sir,
Yeah, nice. Can you tell me what is the formula for R conduction 1?
L by Ka.
Huh?
L by Ka.
Yeah, that's the thing. L by Ka is not the formula here. L by Ka is wrong. Okay, L by Ka is for slab. Okay, you should not consider L by Ka here. Okay, here what
Okay.
you should consider is this one. It is cylinder. For cylinder, it is 1 by 2 pi KL into ln R2 by R1. This formula you have to take. Can you see this formula?
Yes,
This
sir.
is the formula that you are supposed to take here. So
Okay.
that's why I am asking you in particular. Good. So here the formula is 1 by 2 pi KL into ln higher radius. Here the higher radius for the conduction one is R2 by the lower radius, that is R1. Okay. So if you substitute the values here, 1 by 2 pi K. K or steel I am supposed to take here because I am calculating it for R conduction 1. Okay. It is, the value is 15 for steel. The L value is given as 10. And the Ln higher radius, the R2 value is, what is the value? It is 3.8 here and 2.5. You can take it in centimeters itself. No issue. 3.8 by 2.5. Because if I take meters also, they'll get cancelled. Okay. So it doesn't make any difference whether you take it in meters or centimeters because both will cancel in the numerator and denominator, the conversion factor. Somebody tell me this value. Calculate and tell me this value.
Sir, 4.44 into 10 power of minus 4.
4.44 into
10 power of
10 power
minus 4.
minus 4 Kelvin per watt. Okay, that is the thing. Good. Next, R conduction 2 I have to find out. The R conduction 2 formula is this one only, 1 by 2 pi KL into ln. I have to take R3 now because for 2 the higher radius is R3 and lower radius is R2. Okay. Now, if I substitute the values here, that is 1 by 2 pi. The K value for insulation is given as 0.2 in the question, and the L value is 10, and Ln, the higher radius is 5.2, 5.8, 5.8 by 3.8. This is the thing. Somebody tell me this value.
0.033.
Double 3, yeah.
0.0.
Sir, sir, I got 0.66, sir.
Then you are wrong. You have to correct. What I have with me here is 33.65 into 10 to the power of minus 3 Kelvin per watt. Okay, that is R conduction 2. Is it okay?
Yes, sir.
So that should be okay. Now, what is asking you to find actually is your Q. Okay, what is the formula for Q here? The formula for Q you will obtain using this. Okay, using your resistance circuit itself, like your previous thing that you have considered in your slab case. Okay, in your slab case, what you have, if this is your equation, this is your resistance circuit, the equation will be, this is R conduction 1, this is conduction 1, this is conduction 2. So if this is your resistance circuit, the equation will be the temperature change, the delta T, by sum of all resistances, or total, we call it. Okay. So this will be equal to, the delta T here is 330 minus 30 by sum of all these resistances. So what is our convection one? It is 1.59 into 10 to the power of minus 3 plus, what is our conduction one? It is 0.44 into 10 to the power of minus 3. And then what is our conduction 2? It is 33.65 into 10 to the power of minus 3 plus 4.21 into 10 to the power of minus 3. So these are the values that you are going to substitute here. And then you will get the Q value. Tell me what is the Q value.
7452.69 watts.
7452.69 watts.
Watts.
Good. That will be the Q value. Okay, that's what he's asking you to find in the question. So you're done with that. This is the question. This is question one. So the next question is, he's asking calculate the temperature drop resulting from the thermal resistances of hot gas flow. So inside the gas is flowing. Because of this gas flow, what is the temperature drop in the steel tube and in the insulation layer? And within the delta T, what is the value he is asking you to find? Okay. So for that, what you have to do, you have to again make use of this resistance circuit. To make use of this resistance circuit, let me call this T infinity 1. This is T infinity 1 is 330. Let me call this as T1, this as T2, this as T3, and this is T infinity 2. If this is the case, what we have done in our composite wall case, what we have done is we have considered that the Q is equal to the temperature difference by the corresponding resistance value. So if I have to take the R convection one only in the denominator, what I'll have in the top is T infinity 1 minus T1. This is one equation. The same can be equated with corresponding to the second resistance, that is R conduction 2. If I am taking in the R conduction 1, if I am taking in the denominator, the corresponding the temperature difference will be T1 minus T2. And then R conduction 2, it is T2 minus T3. Then R convection 2, it is T3 minus T infinity 2. So what is asking you to find is just the difference values, that is T infinity 1 minus T1 he is asking you to find. If that is the case, what I'll have is it is equal to Q into R convection 1. Okay, I have Q value as 7452.69 into the R convection 1 value is 1.59 into 10 to the power of minus 3. So then I will get what is the T infinity, T1 minus T1 value. Okay, this is the temperature drop within the gas. Then if I want the temperature drop in the steel tube, it is T1 minus T2, which will be Q into R conduction 1. So substitute the values accordingly and you will get that this one T2 minus T3. This is for the temperature drop in the insulation layer. Q into R conduction 2. And then T3 minus T infinity 2 will be Q into R convection 2. So tell me these values. this value is 33.65 into 10 to the power of minus 3. This value is 4.21 into 10 to the power of minus 3. So calculate and tell me these values. These values can be in Kelvin or degree centigrade. Both will be the same because it is the difference you are considering. Yeah, tell me. David, 375. You tell me what is this first value? Calculate and tell me. Do you have a calculator with you, David? David, are you there?
Yes, sir.
Show me your calculator to me. Switch on your video and show me your calculator. Calculate and tell me. All these values, tell me fastly.
Yeah. Sir, first one, 11.849.
Okay. See, I have written the values I have with me here. This will be in hot gas. This will be in the steel tube. This will be in insulating layer. And this will be in the outside atmosphere. You look at the values of the temperature drop. The temperature drop is highest in the insulating layer. Why is it highest in the insulating layer? Because the thermal conductivity possessed by this is very high and the heat transfer is happening by conduction. So among these two solids, steel and insulating layer, the thermal conductivity possessed by this is 0.2 here. It is 15 watt per meter Kelvin here. So because of this reason, the temperature drop you can compare between these two. It is 3.3, very much less actually, very small temperature drop, almost negligible temperature drop. But you look at this insulating layer, the drop is very huge. Okay, what do you understand by this? From this you can understand that the insulating layers can bring in huge temperature drop, and then these insulating layers can actually block the heat transfer, minimize the heat transfer that is happening through a tube. Okay, many times in industry, a hot water is flowing inside this tube, and if you leave it without insulation, whatever the heat that is present inside will come out. Okay, if you don't want that heat to come out, you have to insulate it. When you insulate it, the temperature drop will decrease like anything. So because of that, you will be in position to have the heat within the fluid itself so that it can be transported very well from one place to the other place. That's what the use of this particular insulating layer concept for a cylinder. Okay. I hope it is clear.